All right. Hello, everybody, and welcome. I thought I would give you an update. This is the hand of the robot that we're working on at this point. Um, this is the cardanic joint um, hydraulic cylinder arrangement that we're using to give the robot, in essence, the intrinsic muscles of the hand. Human beings have the intrinsic muscles of the hand inside their hand, and I'm using these to do that for the robot hand. Now, the robot hand also has, just like human beings do, these ligaments, and this is the wrist area here, and so those ligaments are going to go beyond the hand out into the forearm, where very strong pulling hydraulic cylinders are present to give the strong force of the hand. So these little hydraulic cylinders inside the hand are the intrinsic muscles of the hand. They give great dexterity to the hand, but they don't have a whole lot of power. And you can see what I've done with the hand is I've kind of curled over the middle finger, the ring finger, and the little finger, and I've extended out the index finger, or extended it. These are flexed. You can see where I made these hydraulic cylinders transparent so you can see what's going on, but they have pushed out their piston rods significantly, whereas the ones that are curled up, their piston rods are not pushed out that much. The original robot, I wanted it to be metal, strong, for military purpose, consisting of parts. I wanted it to be 2205 alloy stainless steel, which is a very strong material. I don't know how easy it is to fabricate with it, so I wanted the robot to be made of little parts that are bolted together to create the final form. But I realize that there might be people who just want to look at this hand and say, is this for real? Would this really mimic a human hand? And so that, I think, could be done by 3D printing it with plastic, PETG, which means all of these connected parts can be incorporated into one part. They don't have to be bolted together. And so that's what I've been working on. And it's not really that hard, it's just meticulous. And there's been some interesting stuff I send my stuff to LinkedIn. And someone was saying, well, if you have a hydraulic, okay, so you can see, by the way, that these hydraulic cylinders have pushed the thumb away from the palm. It's up here, which they can do. And they're saying, well, if you're going to have hydraulic parts running a hand, the hand is not going to be anything like the size of a human hand. But this is specifically constructed to be the size of a human hand. So I'm going to show you my hand. It was a lady, it was on a talk show, and they asked her what she did for a living. She said she was a hand model. And I'm sure everyone did what you just did and said, what? And she said, I'm a hand model. They like my hands. And so I open a tube of toothpaste, or I turn a light switch on and off, or I pick a shoe up out of a box, and all they're filming is my hands. I'm a hand model. So I'm going to be a hand model, and I am not a good model of anything, I don't think. Particularly in this camera stuff. It just is counterintuitive to me. But I wanted you to see, I'm going to use my own hand, which I think is just a regular old hand. Okay, a normal hand, which is my hand. And we can see that down here at the level of the wrist, it's 2.5 to 3 inches wide. At the level of the metacarpal phalangeal joints, it's 3.5 to 4 inches wide. I say I'm not a good camera model. The whole entire hand is about 6.5 to 7 inches long. The length of the palm is 4 inches. If you look at the hand from the side, at the level of the metacarpal phalangeal joints, it's about 1¼ inches thick. At the level of the wrist, it's 2 to 2¼ inches thick. And one thing I will mention is, if you told someone, can you flex your fingers, or I said, my fingers are now pointing straight up. Can you flex your fingers so they point at the floor and they're flat to the floor, parallel to the floor? And they would go, yes. And I'd say, well, go ahead and do that. And they would point it down like this and say, see, it's horizontal. But what I want you to notice is, see this angle here? Okay, when they were straight up, this angle was straight up and down. And when you pushed them down to make it flat to the floor, this angle changed. So if you grab your hand and force your metacarpal phalangeal joints to remain straight up and down and say, okay, now flex your finger down as far as you can, that's how far it flexes down. And that is not flat to the floor. That's very interesting. You have to remember that, because I think if you ask a whole lot of people, can you bend your fingers all the way down to the floor, they would go, yes. But actually, I don't think so. Pretty interesting. All right, and hello again. I like to bring this in. I mean, I always like to bring this in just to say hi and welcome, and I'm glad you're here, and enjoy. We're having a discussion. That's all that we're doing. I have a YouTube channel. I invite you to subscribe. I think you'll enjoy it. I try to put all of these videos on my YouTube channel. I have a website. You can go to the menu, discussions about a robot. Then you go to this page, give the robot a hand. And on that page, I have some discussions about the robot hand. And I'll also put the links to the YouTubes. So you can just go there and see all the YouTubes. I do, anytime we're talking about a physically real item, it's just important to remind people anything that's physically real might hurt somebody. If you are managing a physically real item, it is my advice, manage it in a manner that is legally allowed and reasonable and safe. And if you cannot manage it in that way, it is my advice, do not create it as a physically real item. All right, and we're back to the robot hand, just looking at it. I'm going to open it up in SketchUp, and we'll measure it and see how big all this is. I do like just to see what Bing has for us. Well, that's pretty. Let's see what this is. Santa Magdalena in Italy. I see myself as wandering down this little path here with my red wagon. I have my robot designs in it. If I can get the CNC people, we'll see what the price is. Maybe we'll have some parts. And I'm trying to get to this beautiful place where the robot people are that have funding and equipment and are building robots. And I'm waving my hand saying, let's try making a robot that really is a complete mimic of a human being. What the heck? Let's see what happens. We'll have to see how that goes. Anyway, thank you, Bing. We'll go back to reality here. And it's time to switch over and take a look at this inside of SketchUp. SketchUp is what I draw in. It's so much easier. And it makes a lot of measurement stuff simpler. And this is a big SketchUp file. The people who create the parts, they want step files, and step files are an individual single part. So what I have to do is go over here to this hand. I can't export this whole hand. I have to take each one of these parts and export it. And I did, let's see, we can take SketchUp and switch it. Right now its length is measuring in inches. So we can do some stuff and see here, like from here to there is 4 inches. There you go. Someone was saying that you can't make a hydraulic hand the size of a human hand with hydraulics, and it doesn't look that way to me. And Well, it's 9 inches long. That's a little bit long, longer than what we had. The thickness at the level of the metacarpal phalangeal joints is 2.1. It was 1.25 for me, and down here at the level of the palm, the wrist, it's 2.2 inches. So it measures out to be the same size as a human hand. I hope that puts an end to this conversation about that. And again, it'd be nice if I could get this all in 15 minutes, but I just don't see it. So I might make a second video. The fingers of a human being, and I use the medical anatomical terms because the physiology people have worked all this out, and I don't see the point of recreating all of these words. So the little bones inside your finger are called phalanges, and the fingers have a proximal means near to, so they take the main structure. So this is the proximal phalange. The main structure is the palm or the hand. This is the middle phalange, and it's just this bone here. And this is the distal phalange. And all of the fingers are, I think I measured my own hand, and all of this is my thumb and my index finger, my middle finger, my ring finger, my little finger. It's just some distances. And each one of these parts, I combined them all together. So the basically the proximal end of the distal, okay, so the proximal end, this is the distal phalange. The proximal end of the distal phalange goes into the distal end of the middle phalange, and there's holes here, and the M1.4 bolt goes through those holes, and this this has this curve in it here so that this can rotate, flex down, and this is bolted to that, and then this is bolted to that, and these two are brought up here and bolted to this, and that's how it works. All right, and we'll have some more technical discussion. I'm just going to have to make another video, but this is the part, for example, here, this proximal phalange that's being moved by these hydraulic cylinders with all these parts that are bolted together, and this is the single unified part. And so I took some of these cardanic joints and the piston rod, and I moved them over to this to show that they fit back together again in the same way as they did in the original model. And the other thing I did was I took the hand, one finger, the index finger, no, the little finger. That's the thumb, so that's the little finger, and there it is pointing straight up, and I moved it down by 60 degrees, and then I moved it down to 78 degrees. And the way I'm measuring that, and I'm going to do some more details about this in the second video. We'll see if we can get this to work here. We'll take this, put that there, and we take this and put it on this rotation point, and that's going straight up through that nut there, and so that's 90 degrees. And so if you go over here and do that same maneuver and then get the protractor and set it here and then bring it to there, and then you go out here to the bottom of those nuts, it's showing 60 degrees. So this has been changed by 60 degrees. And if you do that same maneuver over here, it's been changed by 78 degrees. And I think that's not bad. I'm not sure that that's what the human being has, but we're out of time. So I'll take my abduction. All right, and we're pretty much done. I'm going to take my flexed hand and say bye-bye. We're going to make a hand that can do this. That's our plan.